he wants to travel with minimum cost of minimum distance. So this is the traveling salesman problem. So again I am telling you, so here the salesman has to visit all the cities, okay, with the minimum cost. Okay, so he has to follow the parameters. So first parameter is he has to visit all the cities only once, and after visiting all the cities he has to reach to the starting city, and then all the cities has to be visited, and he has to come back to the starting city in the minimum cost. So these are all the conditions. So we can take some real time example. So real time example is, okay, and delivery person. So the delivery person has to deliver the product to different locations with the minimum fuel. Okay. So when how can he can able to attain this by using the Google map. Okay. So in everyone mobile there is having the Google map. So using the Google map he can able to reach the location with the minimum distance. So that whenever the distance is minimum, so the fuel will be less. Okay. Using that application he can able to attain this goal. Okay. So this is one of the example for this traveling salesman problem. Okay. So for example, okay, in your question they will be giving you the problem statement. In the problem statement they will be given the number of cities and distance between the cities. Okay. So our goal is we have to find the minimum cost. So we have to find out the minimum cost to, okay, that visits each city exactly once. And it has to come up to the starting city. Okay, let us take as an example. Okay, we take as an example. So we have 4 cities, that is 1, 2, 3 and 4. Okay. Okay, let's assume this is your starting city, that is 1. Okay, the salesman can start with the starting city 1 and he can visit to the next city 2, 3 and 4, and within this city he has to come back to 1. Okay, so here we may have a different tour possibilities. Among these different tour possibilities, okay, he has to take the minimum cost. So we will be having different tour possibilities. So we have to take the minimum cost possibility for the traveling salesman problem. Okay, so he can go in any order. Either he can go 1, 2, 3, 4 and 1, or else he can go 1, 3, 2, 4, 1. Like 1, 3, okay, 1, 3, 4, 2, 1. Or else he can go 1, 4, 1, 4, 3, 2, 1. So it may be in any order. So he can go in any order, but the thing is he has to visit all the cities only once, and he has to go back to the starting city with the minimum cost. So that is the main goal of this traveling salesman problem. Okay. So for this only we are using the branch and bound technique for solving this problem. Okay. So let's see what is the meaning of branch and bound technique. Problem into sub-problems. The problem into sub-problems. And next one is bound. So bound means, okay, so whenever the tool is having the upper values, okay, whenever the tool is having the upper values or the maximum value, so not, okay, bound means we are taking the lower value, that is lowest cost. Okay, that is bound. Next one is pruning. We are removing the maximum cost. Okay, we are removing the maximum cost. Okay, so for example, we will be constructing the state space tree by using this branch and row technique. Okay, so here we are taking, for example, we will take that particular graph. Okay, so for that we are going to draw the state space tree. Okay, so for example, the starting vertex is 1. So from that vertex, where and all we can able to go? We can go vertex, let's say 2, 3 and 4. Okay, from 2, where and all we can able to go? We can go 3 and 4, right? And from 3, where we can able to go? We can go 4. And from 4, we can able to go 1. Yes, this is one possibility. And we come to this here. Now 1, 2, 4. From 4, where we can able to go? By using this, we can go 3. And from 3, we can able to go 1. Okay. So like that here 1, 3. From 3, we can go where? 2. Okay. From 2, we can able to go 4. And from 4, we can able to go 1. And here 4, 3, 2, 1. And now, so here branch and bound here, it means like here we will be having a different possibilities for the state space tree. Okay, but we are going to take only the minimum cost, that is the minimum cost for the particular possibility. That is what we are going to take as a final solution. Okay, this is what we will take as a state space tree. Okay, by using state space tree only we can able to do this. Okay. So now the adjacency matrix of the given graph. Okay, so here I'm going to take 4 cities. Okay, and the cities are A, B, C and D. Okay, so this is row and here the column is also A, B, C and D. Like this is R1, R2, R3, R4. Okay, row 1, row 2, row 3 and row 4. Okay, so the first thing here it is we have to reduce the matrix. So how we have to reduce the matrix? First step is row reduction. Okay, so first step what we want to do, we want to make a row reduction. So what is the meaning of row reduction? Okay, let us explain. See, I am going to take the original matrix as it is. The values are 10, 5, 3, 8, 9, 7, 1, 6, 9, 2, 3, 8. We want to find the minimum element. Okay, and here what is the minimum element? 7. And here what is the minimum element? 1. And here what is the minimum element? 2. Okay, so what the next step you want to do? You want to subtract each and every element of your row with this minimum element. Okay, so now tell me, so 10 minus 3, 7, 5 minus 3, 2, 3 minus 3, 0. So like that, 8 minus 7 is 1, infinity, 2, 0. So 1 minus 1 is 0, 6 minus 1 is 5, infinity, 9 minus 1 8. So like that, 2 minus 2 is 0, 3 minus 2 1, 8, sorry not 8, 8 minus 2 6 and then infinity. So after the row reduction, this is your reduced matrix. Okay, now from that, next step is we are going to do the column reduction. So the second step is what? Column. Okay, column reduction. Okay, so now we take this particular matrix. Okay, so what is the value? Infinity, 7, 2, 0, 1, infinity, 2, 0, and then 0, 5, infinity, 8. Okay, 0, 0, 1, 6, infinity. So now this is your matrix, this matrix. Okay, so now in this we are going to do the column reduction. So column reduction means we want to take the minimum element of each column. Okay, so what is the minimum element here? That is 1. And here it is not 1. So here we have 0, right? So then it is 0. So here 1 and here is 2 and here it is 0. Now the same thing, what we done for the row reduction, the same thing is doing for column reduction also. So now in this column reduction, okay, I am going to reduce the number with this minimum element. So now this is 0, 1 minus 0 is 1, 0, 0, 8 and 2. Okay. So after the column reduction and row reduction, the reduced matrix. So this is here reduced. So this is here reduced matrix. So in this reduced matrix, okay, you want to check whether each and every row or the column is having all infinity, or at least one value in each row or column should be 0. Okay, let us check now. So now come to this first row. So here we will be having the value 0. Okay, any row or column may have the value 0. Now this is okay. And here we will be having 0. Then this is also okay. And here we will be having 0. Okay. And here also we will be having 0. That is also okay. Fine. Now the same thing, just do it for the column also. So here we will be having 0. And here is 0. And here is 0. And here is 0. So now this is your first reduced matrix. So this one I'm going to take it as what? M1. That is matrix 1. Okay. So this is A, B, C, and A. Okay. So now from this we will move to the next one. So now here we have to find out the total reduction. So what is the total reduction? What is the total reduction? So total reduction is nothing but, so what is the value for the row reduction and what is the value for the column reduction? Just summation of this two. Okay, now 3 plus 7, 10, 10 plus 1, 11, 11 plus 2 is nothing but 13. This is the row reduction value, that is 13, plus column reduction, that is 0 plus 1, 1, 1 plus 2 is 3. So now this is 3. So what is the total reduction of the first after the first reduced matrix? That is 16. So this is the first reduced matrix. Okay. Now from this, okay, we are going to construct the state space tree. As I already told you, okay, in Travelling Salesman Problem, any one vertex will be the starting vertex. So from that vertex, we have to visit all the remaining cities or all the remaining vertexes, at least one, and we have to go back to the starting vertex. Okay, so for that we have to find out the minimum cost or minimum distance. So this is a Travelling Salesman Problem. So here we are going to use the state space tree. So the state space tree we are using the branch and bomb. Okay. So now in this particular example, I am going to take this A is my initial vertex or the starting vertex. Okay. So now, state space tree. Okay. So what is the starting vertex? A. So from A, where we can able to go? We can able to go B, C, D. Okay. Now the thing is, we have to find out the cost of A to B part, and we have to find out the cost for A to C, and we have to find the cost for A to D. Okay. So among these three costs, which one is minimum? We have to travel in that particular part. Okay. So now I will tell you how to find out the cost of each and every part. Okay. So first we will take the part. Okay. We will find out the calculate B. First thing we have to calculate the cost of part A to B. Okay, so first we are going to find out the cost of A to B. Okay, so how will we find the cost of A to B? Okay, so first thing is you have to, this is A is the row and B is the column. Okay, and part A to B. So for all these things you have to put this as infinity. Okay, so from this M1 matrix, we are taking this M1 matrix, this is your reduced matrix. So from this reduced matrix, you are going to apply that. Okay. So now, listen. So A row, this is A, B, C, D, and A, B, C, D. So A row is infinity, and B column is infinity. This is your B column, right? So just given to infinity, and A to B is infinity. Okay. Sorry, not A to B. Okay, you have to take it as B to A. B to A. So B to A is infinity. So the So for that you have to fill A row with infinity, B column with infinity, and the path B to A to be infinity. So you have to take this reduced vertex, this reduced matrix. Okay, you should not take the original matrix. You have to take this reduced matrix. In this reduced matrix, you just apply all these things, and the remaining values you can copy it from the original reduced matrix. Okay, see A row I have filled with infinity, and B column I have filled with infinity, and B to A. B to A is B row, A column, that value I have filled with infinity. And the rest of the values I have taken it from this reduced matrix. Okay, clear? So now, in this matrix, okay, we have to apply again the row reduction, column reduction, and we have to find out the total reduction cost. Okay. So now, so here we will take the row reduction. So row reduction. So row reduction here. So all are having infinity, and here all are having one value is having 0, and here also one value is having the 0, and here also one value is having 0. Okay, so there is no use of row reduction. See, listen, actually here every row and column, okay, has to be filled with infinity, or at least one value in a row or column should be 0. So here all values are filled with infinity, and here one value is 0, and here one value is 0, and here also one value is 0. So here there is no row reduction. So here there is no row reduction. Okay. So come to the column reduction. So in this column reduction, so here I am having one value is 0, and here all values are filled with infinity. Okay. And here one value is having 0, no need of that, and here one value is 0. So that here also there is no need of column reduction. So that here the total reduction is what? Here the total reduction. Okay. The total reduction is 0, because there is no reduction of row and no reduction of column, so that the total reduction is 0. Now we have to find out the cost of that A to B path. Okay. We want to find out the cost of path A to B. Okay, for that the formula is cost of parent matrix plus reduction and plus value of path A to B. Okay, so I will take the M1 value here, that is the reduced matrix value is infinity 6 0 0, and then 1 infinity 0 0, then 0 4 infinity 8, then 0 0 4 infinity. Okay. So now cost of parent matrix. So what is the cost of parent matrix? So this M1 we have found the cost, no, that is 13 plus 3, that is 16. Okay, so that is the cost matrix. And reduction, so what is the reduction which I have, so I got it, that is 0. Okay, and the value of path A to B. So you know, right, A, B, C, D. So this is A and this is your B. Okay, so what A to B, what is the value? 6. Right? So 16 plus 6, what is the value now? 22. So the cost of A to B is 22. Okay, am I clear? So this is how you want to calculate the cost of each and every part. So I have found the cost of A to B. Now we have to find out the second thing. We have to calculate the cost of A to C. Okay, ma'am. So now you just take this matrix. Okay, and here again the same thing. A row C column infinity, and then C to A has to do with infinity. Okay, ma'am. So now take this. Okay, this is A, B, C, D. Okay, A row is infinity, and C column is infinity, and C to A is infinity. So the rest of the values we just take M1. Okay, so this is 1, infinity, 0, and then 4, 8, 0, 0, infinity. Okay, ma'am. So I hope it's clear, right? So this is your first reduced matrix. From the reduced matrix only. Okay, I'm going to calculate the cost of A to C part. Okay, so first A row has filled with infinity, C column has filled with infinity, and then C to A will be filled with infinity. Okay, so now we just do for row reduction and column reduction. So row reduction, you know, right? Again, I'm telling you, all values or all row or column values must fill with infinity, or one value in row or column should have 0. Okay, ma'am. So let's check here. See, here all values are infinity. Okay, and here one value is 0. Okay, but see, listen here. Here I don't have all infinity, and even I doesn't have one value is 0. So what you want to do in this row? You want to take the minimum element. So what is the minimum element? 4. Now you want to subtract this element with this each element in your row. Okay. And second case here in the last row was one value is 0. So that is okay. So just do the row reduction. So do the row reduction. So the after present row reduction what will be infinity. So there is no change in first row, second row, and third row. Okay, here infinity. 4 minus 4, 0, and here infinity. 8 minus 4, 4, and here just take all the values as it is. Okay, so after the row reduction, this is the one. Okay, now do the column reduction. So in this column reduction, one value is 0 here. Okay, and here one value is 0. Okay, and here one value is 0, and here one value is 0. So here you don't need to perform the column reduction. So now you just find out the total reduction cost. Total reduction cost. So how can you find out the total reduction cost? That is row reduction value divided by column, plus column reduction value. Okay, so what is the row reduction value? That is 4. Do you have any column reduction? No. So 4 plus 0 is 4. Okay, ma. So now we want to calculate the cost of A to C. Okay, so now calculate the cost of A to C is, okay, you know the formula. What is that? Cost of parent matrix plus reduction plus path of A to C. Okay, ma. So what is the total cost of parent matrix? That is 16 plus reduction. So what is the reduction value which I got it? That is 4 plus path of A to B. That is for first one, and for this one we are calculating for A to C. Okay, you want to find out A to C. What is the cost mark? 0. So 16 plus 4, 20. So now what is A to C? The value is 20. Okay, stop. Okay, so we have found the cost for A to B path and A to C path, and the next thing which we have to calculate the cost is A to D. Okay, so we have to calculate D cost of A to D. Okay, so we'll again okay, A to D. So what we have to do? A row has to be with infinity, D column has to be with infinity, and D to A has to be with infinity. Okay, you know the reduced matrix is this one, right? So that is like infinity, like A row has to be filled with infinity, and D column has to be filled with infinity. Okay, this is A, B, C, and D. Okay, and D to A. Okay, D to A is infinity. So the remaining values copy from that. Okay, 0, 0, 4, infinity, and here 0, 4. Okay, so now the second step is we have to find out the row reduction and column reduction. So row reduction, so here all values are infinity. Okay, here one value is 0. Okay, and here one value is 0. Okay, and here one value is 0. So here there is no row reduction, that is 0. Now come to the column reduction. So here one value is 0. Okay, then one value is 0. Okay, one value is 0, and here all are 0. So here there is no need of column reduction also. So that here the total reduction is 0, because here I didn't do any row and column reduction, so it is 0. Okay, now we have to find out the total cost. Okay, so now we have to find out the Okay, now the thing is, which one is having the minimum value, that particular, which one is having the minimum cost, that particular part only we have to take. Okay, so this one, which one is minimum? This is like A to do this minimum. Okay, so now please, we have to take this one is the M2, because further tree, okay, further tree I am going to construct by using this particular matrix. Okay, so this is my M2 matrix. Okay, so from this matrix only you are going to apply it further. Okay, so now from D, wherever you can able to go, you can go B and C. Am I right? So now again you just calculate the cost for A to D, D to B, and A to D, D to C. Among these two, which one is having the minimum cost? You have to travel in that particular path. Okay, so now first we will find out the cost for D to B. Okay, so now listen, so calculate the cost of A to B, D to B. Okay, so now please listen. So here A row and B row has to be filled with infinity, and B column has to be filled with infinity. Okay, and A time B to B filled with infinity, and then B to A has to be filled with infinity. Okay, so you want to apply this in this particular matrix only, you have to apply all these things, because from the D matrix only you are going to implement further. Okay, you want to take this M2 matrix. Okay, so listen, so this is A, B, C, D. Okay, A, D row, this infinity, and D is also infinity. Okay, fine. And now B column is infinity. So this is B column, just put it as infinity. Okay, B to D is infinity, B to B is infinity, B to A is infinity. Okay, fill. Okay, the remaining values you just take it from there. Okay, 0, 0, infinity, infinity. Okay, you know, right? First thing is row reduction. So this is okay, this is okay, this is okay, this is okay, because it's all filled with infinity, and here I am one value I am having 0. Okay, so here one value is 0, here all are infinity. Okay, there is no row reduction, and here also there is no column reduction. So the row reduction is what? 0. Okay, so now we will find out the total cost. We will find out the total cost. So what is the cost of parent matrix? So cost of parent matrix. Okay, what is the cost of parent matrix? That is 16. Okay, 16 plus what is the reduction which is taken here? That is 0. Okay, and then your path from where to where you are going to do? D to B. You are going from D to B. So now in this, you should not take here. You have from the M1. Okay, what is the cost of D to B? So D is here and B is here. D to B, what is the value now? 0. So that is what now? 16. Am I clear? Okay, so you want to take the path cost from this first reduced matrix. Okay, you should not take it from here, you have to take it from here. Okay, so the path cost is 16. Okay, now you have to find out the cost for A to D, D to C. Okay, so now calculate the cost of A to D, D to C. Okay, fine. So now, okay, so here also A row and B row has to be with infinity, C column has to be with infinity. Okay, and then C to D infinity, C to A infinity. Okay, so now, so A, B, C, D. Okay, A row is infinity, B row is infinity, C column, this is the C column is also infinity, C to D. So C is here and here D is here. Okay, so C to D is also infinity, C to A is also infinity. So the remaining values you can copy it from here. Okay, this is very M2, so from that you can copy. Okay, so one for the other value is 1, infinity, and then and here. Okay, so now just check the row reduction. Here it is okay, but here no. So I don't have the value 0 and no values infinity. So here the minimum value is what? 1. Okay, so what what will happen? So 1 minus 1, 0. Am I clear? So first value 1 was present. Okay. So I have either all values should be filled with infinity or at least one value should be 0. But here both these are not there. So what I am going to do, I am going to take minimum value, that is 1. Okay. That is the minimum value. I am going to subtract it from each and every element in your row. Okay. So 1 minus 1 it will become 0. And come to here. So here also the same thing. So what is the minimum value? 4. Okay, so 4 minus 4 will take as 0. Okay, so here the condition is okay. So now what is the row value? 1 plus 4, 5. Right, this is the row reduction value. Column, see this is the column, it is having 0, okay, and here is also 0, okay, here all infinity, okay, and here all infinity, okay. So now the total reduction of this one is 5. Row reduction is 5 and column reduction is 0. 5 plus 0, 5. Okay. So now we have to find out the cost. Okay. Now we have to find out the cost of part A to B, B to C. Okay. So what is the formula? You know, total cost matrix. Okay. What is the total cost matrix of this one? 16. Plus what is the reduction value? 5. Okay. Plus the cost of D to C. So what is the cost of D to C? What is the value of 4? So now 16 plus 4, 20. 20 plus 5 is 25. So now the value of this particular part is cost is 25. So in this two, which one is minimum? 16. So I have to choose B is my third matrix. That is, it is your yeah, this one is okay. This is your M3. Okay, no? No, stop it. So here, okay, the next step is the minimum cost is this particular part, that is D to B. So I am going to find out the cost of next one. Okay, so after B, where we can able to go? We can able to go C. Okay, now we want to find out the cost for B to C. Okay, so A to D, B to B, and B to C. Okay, now so here A row and D row and B row has to fill with infinity. C column has to fill with infinity. And then C to B, C to B, C to A has to fill with infinity. Okay, let's do this. Okay, so this is the empty value. Okay, so now A value has to fill with infinity. A, B, C, D. A, B, C, D. Okay, B row is also infinity. And then C column is infinity. C to B is infinity. C to B is infinity. C to A is infinity. So rest of the values you just take it from here. So this is also infinity. Okay, so now here all values are bottom. So here all condition has satisfied, and here also all condition has satisfied. Right? All the row and column values are filled with infinity. So here there is no need of row and column reduction. So here the total reduction is what? 0. Am I right? Okay. So now please listen. So now we have to find out the total cost. Okay. How will we find out the total cost? Cost of parent matrix. So who is the cost parent matrix for this one? So this is B, right? What is the cost of B to B? That is 16. So 16 plus reduction. So what is the reduction? 0 plus. Okay, from you have to find out the path value of B to C. So B to C. What is the value? 0. So now the value is 16. Again I am repeating. You want to find out the total cost. So for that the formula is cost of parent matrix. So who is the cost of parent matrix? So who is the parent of C? That is B. Okay. So for this B matrix, okay, what is the cost? That is 16. So that I am making it as 16 plus reduction. So reduction means for in this particular reduced matrix, what is the total reduction you have taken? Okay, here there is no row and column reduction, right? So that is why I am taking it as 0. And then what is the path value of, okay, path value of B to C. So in B to C, what is the value? Path value 0. So that is why 60 0. Okay, 16 plus 0 plus 0 will be getting 16. So now what is the cost of this one? 16. 16. Okay, so from this C you can go to the matrix what? A. Okay, you can go to matrix A because this is our final destination, right? After visiting all the vertexes, all the near all the after visiting all the cities, we want to reach again to the starting vertex. Okay, so now, okay, what is the final minimum cost? What is the final minimum cost now? So from for the given graph, the minimum cost of traveling salesman problem is 16. So this is your final answer. Okay, even you can able to check it that one. Okay, you can cross verify that. Okay, how you can cross verify that? So listen. So we are going to take this particular path. Okay, what is that? Okay, we are going to take this A. From A we are going B. From B we are going B. From B we are going C. So from C we are going again to A. Okay, so we will be having the original matrix. So from A to D the value is 3. Okay, and B to B the value is 3, and again B to C the value is 9, and then C to A. So the C to A the value is 1. Just add all these things, that is 3 plus 9 plus 1. Okay, so 9 plus 1 10, 10 plus 3 13, 13 plus 3 is 16. This is the final answer. Okay, so these values you can you have to take it from the original matrix which is given in your problem statement. Okay, so from that, okay, we found that